Okay, seems to have stabilized a bit. Hello, my name's Simon Brown. I'm hosting this webinar today. I'm from the Met Office. I'm involved in managing the science for extreme weather research. Today we've got a talk from Murray Dale, but if we have the next slide, please, I can give a overview of where we're going today. So I'll give a quick program news update, and then we'll move on to the main item, which is Murray Dale from JBA Consulting. We'll then have a response from Katy Peat, and then a Q&A session at the end. Next slide, please. So if you wish to engage in this webinar, this is how we're going to do that. We'll have the presentations first and then a Q&A session at the end. Put your questions in the Q&A box tool and upvote the ones that you want to be posed first. Everyone will remain muted unless enabled by the host, which is me, and the webinar and audio and slides will be shared after the event. If you have technical problems, do put them in the chat and someone will come along and give you a hand. And just so everyone knows, the webinar will be recorded, so make sure you're happy with that. Next slide, please. This is the only bit of news for today. A recently published article from Cardiff University about the public perceptions of climate risks and adaptation in Northern Ireland. And there's quite a few points there, which I won't go through in any detail, but do go and check it out from that web link at the bottom there. The only points I thought I would be interesting to notice that the first bullet saying that only 5% of the population think that climate is the top issue, which maybe feel a little bit worrying. But if you then go to the bottom bullet, the most trusted source for climate information are still scientists, which is a positive for us and for this sort of webinar that we're giving today. Next slide, I think, please. Okay, so our speaker today is Murray Dale from JBA Consulting. Choices for the future of UK climate information. Murray is a chartered meteorologist with 30 years of experience in hydrometeorology, climate resilience and water management. He is the principal investigator of the UK Climate Resilience Programme project called Climate Information to Inform UK Decision-Making and Climate Services Standards and Value. He was also a co-investigator on the Future Drainage Project and is the Climate Resilience Lead within JBA. And so, Murray, over to you.
Thank you very much, Simon. I'll share my slides and then get going. Right, it's a pleasure to be with you today. I'm going to talk about a project that's one of quite a few projects in the UK Climate Resilience Programme, and this webinar series has been talking about a number of these projects. So this project was initiated just over a year ago, and it has involved quite a few folk from around the UK, has also made some consultation with people abroad, and so I'm going to give a presentation about the overview of the project and the results, which are slightly in draft form, but we're quite close to finalising those, and we're very pleased to have with us Katy Peat from Defra to make a response to this presentation. Katy was involved in the project as well as one of the stakeholders. The aim of this project was to produce recommendations for the next steps needed to produce climate information to inform UK climate risk assessments and adaptation decisions of the next decade. So it's had quite a broad remit, and I think it's fair to say that it's been a challenging project to work out how to deliver it. There's been a lot of discussions about how this should be done, and I think that a lot of that's been very helpful and beneficial. So I'll talk about some of the outcomes which perhaps were maybe not foreseen at the outset. It's may be useful to define what we mean by climate information at this stage. So we're taking this definition here that says climate information comprises data, models, forecasts, and projections relating to the observed, historical, or current climate, as well as the simulated future climate over different time horizons and spatial scales. And it can be provided in numerical or graphical format based on observations or model simulations for different spatial and temporal resolutions over different time horizons and geographical domains. So what it isn't really is the derived product and impact assessments that might be developed from climate information. So really it is a very broad term that covers anything, whether it be data or quantitative or qualitative information that can be used to inform decisions. But it is often taken forward to develop climate services, and there's separate projects in the UKCR programme about climate services, which may be useful to some people to find out about. The delivery team for this project involved colleagues of mine at JBA, so Rachel Nye, Rachel Brisley, Emma Brooke. Rachel Brisley's moved on to work for Ipsos now, but was involved in this project in the first half. And also Marie Ekstrom, who was until quite recently with Cardiff University, and Becky Benton, a chartered meteorologist and independent. We've also had a lot of input and benefit, particularly in 2022, from the UKCR Steering Committee, and in particular, Rowan Sutton, Harriet Orr, Katy Peat, who's speaking today, and Paul Bates. So I'm grateful to all of them for their inputs. Those four people voluntarily gave up their time to help inform the way in which we should have a workshop on this project, and are members of the UKCR Steering Committee, which is, you can find that full list of committee members at that web link at the bottom of this slide. The way in which the steering committee interact with the programme is shown in that graphic at the bottom left. And I'd also like to acknowledge the input from the Met Office team in this project. So Zaritza Jones as the project manager, and Jason Lowe, Simon, who's on the chairing today, and Peter Stott, all scientists at the Met Office from the Hadley Centre, and they all provided a great deal of assistance and steer with the way in which the project was run. So I'm grateful to all of them. If you're familiar with the UKCR programme, you'll know there's a website which has got lots of images of all the projects which are ongoing or recently completed, and this project sits in there. If you go into the projects tab, you can find about these projects, and there's an image of this one with a sort of see-through globe that relates to this project. There were 4 steps to this project as we set them out earlier on. It was originally intended to be a 6-month project, but due to a number of the challenges we faced, it's extended to something like a 15-month project now, but it's pretty much completing this month. So we went through desk-based exercises, looking through user needs and user assessments. We ran a workshop last summer about user requirements. We formulated a report that was looking at what the climate science ask would be. And then we had step 3, which was a longish period in which we developed options for what might be the future priorities for climate information. And then we've gone through step 4 most recently to prioritize these options and to formulate a set of recommendations. So that's where we are at the moment, and this webinar is happening pretty much at the 99th part of the project, so we're just finalizing recommendations, but are pretty close to completion. On step 3 there, the options development element, we needed to do that following the something like a sort of a gateway between step 2 and 3. Now, what happened after the workshop we had last summer was there was an identification that there could be seen to be 2 tracks to the way climate information is important and is treated in the UK. So there's track 1, which is about how decision makers who use the climate information would benefit from improved guidance, but also these bullet points came out of that workshop. So how to use existing information, identify critical thresholds and tipping points, and here we're referring specifically to user-focused thresholds and tipping points rather than climate science ones, understanding extremes, and then there was certainly a lot of interest from users about being able to understand what climate services are available and what guidance is available to use to make use of these information. Then there's a second track which is related to climate science developments, and this project was given the steer that it should be focusing more on track 2, so it has done that, and there are elements there that were seen as important from the initial workshop, and those have been dug into quite a bit further from that last summer. And you'll see in between that there's a question mark, if you like, or an opportunity, I could say, as to how these 2 tracks might interact, and we'll talk a bit more about that as we go on. So during the autumn of 2021 into the winter and into January, we developed a survey which went to 67 UK and international climate information providers. And the idea of this survey was to elicit views on people's interpretation or priorities regarding a set of climate science questions, which in some cases can be seen as trade-offs or tensions. So for example, if you have the opportunity to have a large ensemble size, you can get a better understanding of uncertainty in climate projections. But to have large ensembles may be challenging if you're wanting to have high resolution, spatial or temporal resolution. So there are trade-offs to be made there. And there's only so much money, time and budget in what climate science and modelers can do. So it was useful to get an impression on people's views about which were the priorities that should take precedence. We also listed views on science and modelling topics that were identified in the workshop and made reference to the CCRA3 climate risks. So we wanted to keep the climate information providers focused on UK climate risks that have been identified. The feedback from this survey was split into 4 sections. We were understanding what people's priority research was to get a feel for what they were doing, and so could interpret their responses as a result of that. Then how they feel or felt that models should be developed, model development should proceed. Then their views on how models are used, and lastly how they consider uncertainty and the options that exist for exploring uncertainty. So the first element of that demonstrated that people were interested in probability, extremes and impacts, in temporal, spatial resolution and probability, interfaces and interactions, whether they be land, sea, coast or socio-economic interactions, how uncertainty is managed, and considerations around model inputs, errors and biases. So these were the areas of specialisms that were probably covering the majority of the people who responded to this survey, and a word cloud above that shows the number of uses the number of times words we use to give an indication of things that are important, and extremes does seem to emerge as an important area. When we analysed the results, we felt it we looked at ways of how we might differentiate between different groups in those who responded. We got about 20 responses to that call, some of which came from the USA and I believe South Africa, but the majority UK based. And one way we found that could be useful at looking at responses was to see whether these climate information providers were members of research or academic institutions, or they operated in more an applied science background. So you can imagine there are some people who are providing information, climate information, but are also using climate information, and the Environment Agency is one example of that. And this showed that when people were interested, feeding back on what was important to them in terms of model development, there was some variation between these two groups. So you can see here that the research academic climate information providers are interested in better models to improve the understanding of the climate system, better models leading to improved metrics, keen on large ensembles, keen on very high resolution global runs. And then the applied science group demonstrated a bit of bias towards increased interest in these final three things of ultra high resolution local runs. By ultra high, we tend to mean convective permitting modeling, additional Earth system components, focusing on explaining the modeling methods. When we then got results for the series of questions we posed about how models are used, in this case, we tended to see a bit closer agreement between these two response groups, but there's some evidence here that there are some things are seen as higher priority than others. So for example, making use of existing models and data, storyline approaches, transient simulations. This is simulations that extend through the century, for example, as opposed to being a fixed output period. And then towards the right-hand side, compound parameters, bias-corrected outputs, and demonstrating data use. So they got somewhat higher priorities than a few of those areas in the middle. So this analysis helped us inform a workshop which we were able to run with the UK CR steering committee, and helped identify where this project was going in terms of the recommendations it was going to be producing. The idea being that we wanted to be as inclusive as possible with this group, and there are obviously strong views and opinions on some of these aspects which may be shared by some and not by others. So we wanted to try and be as diplomatic as possible in our recommendations. You'll be able to see how you feel about them when I get to them shortly. We then involved the steering committee from the UK CR programme in a workshop where we tried to take a deeper dive into some specific areas of user need. So this isn't saying these are exhaustive by any means. These are just 3 areas of user need that came across as important, and we felt it would be useful if the workshop could delve into these a bit more. So this aspect of tipping points and thresholds, by which we mean user-focused tipping points and thresholds, rainfall extremes, which is an area of interest for quite a few, and moving from the current near-term future climate, from the current to the near-term future climate hazards. This requirement of many to see how we transition from observed to current to near-term future climate, and that process. This is a slide to illustrate what we mean by these user-focused thresholds. So there might be a user-focused threshold of an important set of parameters relating to heat waves in London. As I understand it, these values for heat waves in London are now superseded, but this is just to illustrate that there's a daily maximum temperatures in excess of 32 degrees and minimum temperatures in excess of 15 degrees for at least 5 days was previously the definition for heat waves, and these things are being revised as more climate information comes along. So I understand that's been superseded now, but that gives you an example of a type of threshold that we're talking about. Then these can affect all sorts of other sectors. So in the water resources sector, drought is an issue which has been seen to be affecting Scotland, with projections that it could be becoming more frequent. And so there are thresholds that can be identified there. And then in terms of a topical issue in the news in recent weeks and months to do with storm overflows from sewer systems, and the fact that those who are trying to manage these overflows need information about rainfall for specific timeframes and with specific thresholds. So if those developing climate information have an understanding of why some of these thresholds are important, it can help focus how climate information is developed. With rainfall extremes, we've got this opportunity now since 2019. We had UK CP18, the climate projections that came out of the Met Office in 2018. In 2019, some high resolution outputs were released, and they were re-released in July 2021 with a fix made, an improvement. And those have presented a sort of step change in what we can how we can understand particularly rainfall intensity change as it affects often surface water flooding, sewer flooding, but also extreme rainfall. So the benefit of these high resolution simulations are that they can capture convection in the atmosphere and represent convective processes. And that's been enabled us. There's a project in the UKCR program called Future Drainage, and there's an output from that on the top right, led by Newcastle University. And Met Office and JBA were involved in that. We produced outputs, that project produced outputs in the form of maps which demonstrate how much rainfall increases are likely for different return period events. And that information has been used to inform new allowances that the Environment Agency have put on their website in the last couple of months, and SEPA have been involved in that as well. So there's an area of understanding with rainfall extremes that's important, making use of things like convection permitting modeling, CPMs. This is important for the bottom right, the day-to-day situation. Okay, this doesn't happen every day, but we are seeing incidents where urban drainage systems can't cope with the increases in rainfall intensity, and this tends to happen somewhere in the UK every year. But we are also seeing the potential for more extreme, what are termed probable maximum precipitation, PMP estimates, that might be changing, and a method for assessing whether those extreme PMPs might change could be using high resolution modeling. So that example of the Topenden Reservoir from 2019 is a case in point, because reservoirs are particularly assets that may be vulnerable to probable maximum precipitation, and they need to demonstrate that they can pass high, very extreme flood flows. The other user need this workshop looked into was this moving from current to near-term future hazards. And so on the right there is an image from the recent allowances that have been produced by the Environment Agency for all flood risk assessments that covers England. So that's an example of the way in which information has been used to try to understand current climate and make use of future climate. But there are obviously issues about how we get between the two places. So that was looked at as well. Now, following the workshop, following the survey and other discussions, we have now come up with a set of, I call them final draft recommendations, because they're waiting to be signed off, but we believe these are quite close to what will be the final set of recommendations for climate information requirements. So these are particularly requirements or areas that providers of climate information we hope will be focusing on, having been driven by user need. So these look at better understanding extremes and the transition along the continuum from historic to current, through current to future climate, and being addressed by continued use of large ensembles, but also high resolution modeling. Validating CPM projections, that's convection permitting modeling projections, is seen as important. Better understanding compound parameters, so those are parameters that might be operating together, and where there are thresholds that might be coexisting so that one is impacting another threshold. Estimating very extreme rainfall and PMP rainfall. Understanding user impact thresholds better, which can be done with closer engagement between users and providers. Clearer information on the skill in seasonal and decadal climate predictions that could be timed. And maximizing use of existing models and model outputs. So this is to demonstrate that we're getting the maximum value out of all the modeling and work that has gone on so far, and not trying to reinvent wheels to develop new models when existing models may be perfectly reasonable for the purposes that they're being used. So that is this set of recommendations that's come out from quite a lot of analysis on this project. One thing that is of interest that has also, I guess, if I show the previous slide, in a number of cases we're talking about closer interaction between users and providers. And here's an example from the final workshop that was held in May that illustrates this point, I think. So there was a question posed about what would be the optimum CPM spatial resolution. So this is a convective permitting model resolution. What would be the optimum resolution to get, say, 30 millimeters in 1 hour rainfall estimates? And someone from the user community said, this is not a question for us, it's a question for the scientists. And someone from the science community said, well, if you leave it to the scientists, then we may make choices like size ensembles, diversity in driving conditions, which may not fit the user's requirements. So I think this is a good illustration of the fact that there is a need for these groups to work more closely together and to understand each other. And that can mean language as much as anything else, but it also means understanding what the priorities for users are when they're trying to make decisions, and also the users understanding what the scientists are having to go through to the choices they need to make about what's important. So we've got scientists and modelers, and maybe there's a scientist or modeler of the future represented on the left, and we've got users and industry or government perhaps on the right. The question is, how do these groups engage? How can they improve collaboration? One opportunity is the use of a science translator or translators. There's a recent paper that refers to these people as boundary managers. But essentially, there are people who need to understand, maybe on the right, what is an important temperature threshold for the health sector, and speak the language that the health sector go through when they're making decisions. That science translator needs to be able to understand that language, and they also need to be able to understand what an ensemble is, what an ensemble size means, what spatial resolution means, what validation of models means. So that there's an opportunity for this group, these specialists in the middle, to help align the needs of the users and the questions that scientists and modelers have to join that up. Another way of doing this is to try and bring these two groups together. So it's gone there and it's gone back again. Let's bring them together and then have a coordinator or facilitator who can engage these groups and help coordinate that engagement. I think it still would benefit from science translators to support this, but there are opportunities for this to happen as well. So my last slide before I hand over to Katie is a conclusion slide to wrap up what we went through on this project. It originally was envisaged as a 6-month project, but it raised a lot of questions and there was a lot of head scratching going on with all groups, I think it's fair to say. So we've had a 15-month project in the end that's nearly coming to a close. And it's managed to coordinate, I think, a wide range of views on the requirements for climate information, and while considering the challenges that the providers are facing. It has arrived somewhat at a consensus with agreed recommendations for providers of information to support user need. And I think it's demonstrating that there's a strong need for closer collaboration between the user and provider communities, which may be no surprise to some people, but I think it is an opportunity that perhaps wasn't that evident at the outset, which I think has been demonstrated well through this exercise. On the right are just a series of concept boards we've used through these workshops to gain people's understanding of what they want. Okay, thank you. I'll pass on to Katie now, and if you're able to unmute, I'll advance the slides as you require.
Thanks very much, Murray, and thanks to UKCR for inviting me along to respond today. I feel a lot of sympathy with Murray and the team for some of the delays that they experienced within this project and some of the difficulties in pulling some of this together. But that said, I think there's a timeliness element to this, and actually having that slight delay in the programme has led us to having this conversation at what is actually a very good time. So thinking about where we are now, we're coming to the end of the 6th assessment report from the IPCC, with the synthesis report due out later this year. We've also finished CCRA 3, so that was put before Parliament by Defra at the beginning of this year, following the independent assessment that the Climate Change Committee completed last year. We're already thinking about CCRA 4, which I'll come on to in a moment, but that won't be due out until 2027. And we're also trying to work with CCRA 3 to think about how we take that forward into actual adaptation action through the 3rd National Adaptation Programme, which is due for publication next year. Now, all of this is happening, these sort of watershed moments are happening against a backdrop of exploding advances in climate science. So thinking about some of the advances we're having in digital twins, Murray touched on what we can now get from UKCP local in terms of this convection permitting modelling. And you know, I know there's a lot of work going on in the scientific community to try and scale that up to even a global model, to have that very, very high resolution modelling running there. So we've got all of these new advances in science and trying to work out how best to use them. And there's no better time than now to be thinking about that. But I would sort of say against that backdrop, there is a sense of urgency around all of this. You know, anyone who's looked through the latest IPCC reports won't be left in any doubt what the messages are. We have to act now, both on reducing our emissions, but also adapting to the changes that we expect to see. And we've got a very, very challenging window in which to make those changes. So when we think about what climate information we're going to take forward in the next round, we have to be very, very careful, very strategic, to think about what is going to really get us over the line on this. So any new climate information that we want to see from a government perspective really has to have a clear line of sight to decision making, and has to change our capability. So that's allowing us to support action, or it has to give us insights that we don't currently have from existing climate models. Preferably it will cover both of those things. But if we move on to the next slide, please, Murray. There's a number of ways that we take our guidance on where we should be focusing our attentions in terms of climate information. And this is just looking at what we're trying to get out of the current capability that we have through the UK CP18. Now, that's been out for several years, and it's giving us some great work out the other side of it, but we're always keen to improve on what we've already got. So we've convened a group of expert users, users across all sectors, who are currently trying to use UK CP18 in their day-to-day work. And what we're doing is we're working with them to co-develop and co-scope a number of additional products that can support the use of UK CP18 further. So we've got a number of strands within that group looking at knowledge sharing, so things like co-authored guidance and peer-to-peer interactions, improved understanding such as entry-level materials, but also more bespoke guidance on particular products, improving access to UK CP18. So that's looking specifically at the UK CP18 website that the Met Office host, and also the user interface, and also considering certain advances in data access. So looking at tools like Esri. I don't know if any of you have seen the climate portal that has been developed between Esri and the Met Office. It's starting to utilise certain aspects of UK CP18, but we're really keen to make sure that whatever we have is as accessible and easy to use as possible. And we're really exploring how we can do that. And then there's additional data sets, so things that could be added on to UKCP, things looking at sort of at the lower end, looking at whole events such as rainfall events or heat events that can be clarified through the projections, but also maybe looking at some larger scale products, things like extremes and downscaling existing products. So if we move on, the other side of what we're looking at the moment is the government side, which is considering CCRA4. So it seems very soon to be doing this. We've got another 5 years to get it out, but we're aware that the earlier we start, the more information we get and the better it is. So CCRA3 came out earlier this year through Defra, based on the independent report that the Climate Change Committee did. And that utilised a lot of UK CP18. UK CP18 was particularly targeted around informing the third CCRA, but some of it wasn't included, and specifically the UK CP local data, which wasn't available in time for a lot of the research products that underpinned the technical report within CCRA. So we're really keen to make the most of this new information. So UK CP local, also information on socioeconomic pathways that we now have, and to take that forward in terms of how we understand risk assessment. So what we can look at in a lot more detail is how do risks vary regionally and locally. So looking at a bit more clarity, not just a national once assessment, but looking at how that changes across geographies, and how we can look at locally specific hazards. And a big part of CCRA4 is going to be around economic analysis. So we understand that a lot of what we need to do in terms of adaptation is going to come down to funding and finance, and having that evidence base there to support that will make things a lot easier. And one of the things we are considering as well is how to increase the utility of CCRA. So we're currently looking at CCRA3, all of the information that's in there, and looking at how to take that forward, and in terms of creating a test bed for CCRA4. The other things that we're thinking about with CCRA is around how we can consider interacting and cascading risks, and looking at a lot of the UKCR programs and projects, things like the indicators work that was done by Nigel Arnell, or the OpenClim work that's being done by Tyndall Centre, to see how that can support the next climate change risk assessment. So if we move on, this is just a bit of a reflection on our engagement around CCRA and the third National Adaptation Programme. So any of you that have worked on these levels of risk assessment, or perhaps on the adaptation reporting power, you'll appreciate that a lot of the work that we do trying to understand risk these days is dealing with warming scenarios, specifically looking at how we can deal with both 2 degrees and 4 degrees of global warming. Now, getting risk owners to understand how 2 and 4 degrees will alter the risks that they face is a very difficult task, and we've gone through many iterations with the Met Office and other information providers to look at how we can do this. For those risk owners that are a bit further along that journey and really got to grips with their hazards, we're seeing some very common refrains coming out, which is at 2 degrees you can manage your risks incrementally. It's a bit of a tight exercise, but it can be done. Whereas at 4 degrees, for a lot of people, what they're finding is that their systems are breaking, and this is becoming quite problematic for them. Now, this is useful for transformative action, but we do need to better understand both likelihoods and timings to be able to take this forward in a meaningful way. So if we move on to the next slide, please. Thank you. So in terms of enhanced capability, which I mentioned up front, things that will really help us do this and the things that really need to be at the heart of any future climate information provision are thinking about timeframes. So that's coupling warming scenarios to timeframes, which could be done with existing data, with just a different framing of what we already have. Early warning signals, it's this idea that Murray touched upon of thinking about near-term hazards, but also with those areas where we have less certainty around what the impacts are, whether that's because they're currently outside of the likely bounds or because we don't have enough information to be able to quantify some of the uncertainty around them. Some early warning signals that could tell us which way things are going would be very helpful. Extremes are another things that come up very, very commonly and has been well captured within this project. And higher impact, low likelihood or hill scenarios. It can be the other way around if you've seen it in the IPCC reports. And also, if you think they're low likelihood, I think it'd be interesting to explore some of the terminology around that, because it's not necessarily that they're low likelihood, but perhaps unknown likelihood is more common. But some of these major climate tipping points that could have quite severe policy implications or very significant operational implications are things that we need to understand better. And finally, storylines. It comes up again and again when we talk about climate information that we want. There's not necessarily a lot of understanding about what a storyline is, or there are a few dispersed examples of what storylines are, but I think this is something where we need to take this further. So apologies for taking a little bit more time there, but that's a bit of a rattle through what the government really want to see out of this in terms of our next steps in terms of developing climate information. I'll leave it there, and I think we're going over to questions.
Katie and Murray, thank you very much for both of those. Very interesting and obviously very pertinent. People do put your questions in the Q&A box. We have one at the moment from an anonymous attendee. I'll just read it out. Why science translator, not decision translator? Why is it a science first frame rather than a decision or context first frame? The provider and user frame suggest only the science side has relevant information to share. This is clearly not the case. How can science and practice be brought together more effectively to ensure there is greater adaptation action? Does research have to be set up differently to support national policy and local practice? I don't know, does anyone feel wanted to jump into that? Katie, it might be more on your side.
Yeah, it's a very, very good observation, I think. And I think certainly within government, we do feel like we have a bit of a science translation role there, and trying to bring policy and practice into some of this. I completely agree. I think there is a need to maybe take a step back and look at models of risk assessment, because depending on which way you approach your problem, you might find that it's a science first question, or you might well find it's a vulnerability first question, which pushes the decision much more onto the practitioner side of things. So I think this is something that we have been discussing within the community, is how do we better elucidate some of these questions around what risk assessment actually is, or what operational adaptation actually is, and take that forward. But yes, I think there are a number of ways you could term the role, but it's a point taken.
Murray, would you like to add on to that?
Thank you. Yes, it is not, well, there's 2 or 3 questions in there, I think, so all very useful and interesting. And the way we term this person, I don't think it matters enormously. I think they may well be a decision translator, they may be a science translator or a boundary manager, which whatever we like, but they're an interim person. Some people have called them a broker, who ideally will be able to understand both the needs of both groups. And it's important because there's a moment, currently a gulf, I would say, in between these two groups. So there are many positive cases where they have worked together very closely, and it's perhaps not a gulf in every case, but there is still, I would say, a significant issue with understanding the issues that both communities are facing in terms of provider and user. And I fully agree that the users need to be informing the providers as to what's needed, and that it should be that way round. I think the providers want that as well, but there is this requirement for them to make quite scientifically challenging decisions about how best to invest future programs of work. So anyway, hopefully it's an area that can be picked up, because I think it's very important.
Thank you. The only bit I was going to add to that was just reflecting on the project that you've been part of, Murray, is that halfway through we did exactly what you recommend we don't do, and that was to separate them apart, the two sort of channel tracks that we had. I know we had to do that for practical reasons to get the project completed, but that sort of is indicative of the challenge that to solve the problems in one of the groups, you sort of need to focus in that group, which then excludes the other group. And so there we don't have that knowledge transfer. So, or it's much harder when we naturally separate to the two to try and solve the problems that each group owns and tries to has a responsibility for. But so it's a very embedded, ingrained problem. Okay, we've got a few more questions. How about this one? This is a quick one for you, Murray, I think. When scientists were consulted, was it mostly modelers or were other communities involved, i.e. the observation community?
Well, we didn't specifically target the observation community. We targeted those that we were aware of and those we were made aware of from others that would be good people providing climate information, whether that be doing so through observational data or climate modelling. So it wasn't designed to be exclusive to any group. I would say probably the majority were involved in climate modelling, but I'm not sure the exact percentages. I think quite often people can be involved in both sides of that data set.
Thank you. One for you here, Katy. Storylines is definitely a growth area in science. Could you say more on what is Defra's take on these and what would you like to get from them?
Thank you. It's I think we're still putting together our case on what we want from storylines. There are two ways in which I've observed them being useful, and one is in the sort of retrospective sense in terms of an analysis of an event that's already passed and using that to learn for the future, and those can be very, very successful in helping manage particularly incidents or sort of acute impacts of climate change, the things that we might see on sort of shorter scale terms. Beyond that, I think what we're looking at in terms of storylines is maybe a sort of modelling first approach to, I think, particularly understanding cascading risks and also potentially hill events. So one of the things that we've been discussing with the Met Office in terms of the high impact, low likelihood dialogues is how to contextualise these within a policy context, thinking about how we explore the uncertainty and the timings, but also the domino effects that they could have in them as well. So drawing out a more sort of qualitative story from what we do know, and being able to explain that uncertainty in a bit more of a policy-friendly way. But there's still a lot more work going on there, and I really welcome any input, to be honest, that people have in terms of developing this.
Thank you. One more question. So at the moment, There used to be a knowledge boundary spanning body, the UK Climate Impacts Programme. Could something similar be funded in the future?
That feels like it's a question for me. Yeah, there was UK SIP, and there was after UK SIP was wound down, although they do still exist in some forms. There was the Climate Ready programme, which I actually worked on whilst that was up and running between 2012 and 2016. There is a huge role for these boundary organisations. I think they're incredibly useful. They don't have to just be within government. They can be within other bodies as well, whether that's the private sector or more widely across academia. It is something that we're thinking of taking forward, and there has been another UKCR project on climate frameworks, which Louise Wilson and Nicola Golding led on, which I was also responded to. It's something that we are discussing quite heavily at the moment, and trying to understand where we would need to coalesce about not just science translation, but also sort of provision of products, and even potentially sort of regulation. But those are still sort of being very early stages of discussion, and yeah, there's nothing concrete to share on that at the moment. But yeah, it is a very good point.
Thank you. That is it for questions. Unless anyone else quickly type up a new one. Doesn't look like it. Well, can I thank both Murray and Katie for bringing their insights to this webinar, and thank you everyone for attending and joining in, and I wish you a good afternoon.